This video goes over question 4 of the business optimization assignment. A commercial cherry grower estimates from past records that if 18 trees are planted per acre, then each tree will yield an average of 32 pounds of cherries per season. If for each additional tree planted per acre, up to 24 additional trees, the average yield per tree is reduced by 1 pound. How many trees should be planted per acre to obtain the maximum yield per acre? What is the maximum yield? We're going to treat this like it's a demand curve and a revenue function. So this axis, the vertical axis, is pounds per tree, and the x is trees per acre. And they gave us a point on that, essentially what is a demand curve. So they gave us the x is the number of trees planted per acre is 18, and the y is 32 pounds per tree. And I'm going to label that x1, y1. And then they tell us the average yield per tree is reduced by 1 pound. So we're going to write the slope as -1. And if we have a point and a slope, we can find the equation of that line by using the point slope form. And if I'm using it, I write it down, I label my point and my slope. Now we can substitute in y minus 32 equals -1 times x minus 18. I'm going to distribute the -1 inside the parentheses, giving me negative x. Negative times negative is positive. Now I'm going to get y by itself by adding 32 to both sides. So y equals -x plus 50. Then I'm going to relabel that as p of x, because I'm going to treat it like a demand curve, -x plus 50. And then I'm going to call this like revenue. Revenue as a function of x is x times p of x, or -x squared plus 50x. And I'm going to go to the calculator. So I'm going to add a graph page, change this to p of x, -x plus 50. And then I'm immediately going to put in my revenue function, or total number of pounds. So we'll call that revenue is x times sine p of x. And now I'm going to go to a calculator page, take the derivative of the revenue function, tab to get to the right place, revenue function of x. So I get 50 minus 2x. We're going to set that equal to 0 and solve for x, which is going to be 100. So comma x. Oh, so 25, not 100. So in order to get the highest yield of blank, 25 trees should be planted per acre. And we can go to the revenue curve and put in 25, so it'll be 625 pounds for the entire acre at 25 pounds per tree. Well done. Now, if you want to learn how to do a good window, so for my demand function, we're going to go ahead and set in -10 to, so they said 18 trees plus 24 more additional, so let's go up to 50 by 2s. And then we know that the y-intercept is going to be 50. So I'm going to put in a little bit of extra leg room, tick marks every 5. So there's a nice picture of my demand curve. And the tree or pounds per acre, or the revenue function is what I'm calling it. We're going to use the same X window, but it needs to be a lot taller for Y. So I'm going to add another graph page, and go call that revenue as a function of x, and it's x times the demand function. We'll hit enter, menu for 1. So -10, let's go a little bit further to 60 by 5s, and then say -200 to 700 by, say, 50s. So we get a nice parabola there. And that concludes this video.